Hello, please let me know if you can hear me. Can you see? Can please let me know if you can hear me? Can you see the video? Let me. It seems to have some problems with the video. For some reason, it's not streaming my presentation. I have to check. Please give me a couple of minutes more. In case we can't bring the video up, I'll just upload the presentation and I'll paste you all the necessary links on the chat of this window. Again, I apologize for this. Okay. Thank God. Now I can begin. Again, I'm sorry about this. There was a problem with my computer. I had to change it, and for some reason it could not connect to the internet. So, I'd like to welcome you here. The presentation will be in English since this webinar is done as part of the Potsdam and European Robotics Week, and also part of our continuing series of webinars on computer programming and STEM subjects. My name is Alexandros Kofteros. I am a teacher in primary school in Cyprus, and I'm part of the Erasmus Plus Potsdam project. Now, a few things about the European Robotics Week. For those not familiar, this is a yearly event. It's organized since 2011. This year is going to take place from the 14th. Actually, it has started up to the 25th of November 2019. This year, there are more than 5,000 robotics events planned. And we will show later the website from which you can download a lot of material, logos, and also organize your own events. This webinar is in two parts. In the first part, we will show the website where you can log your European Week of Code events, and also how to organize your own event using the resources from the website. Now, there are a couple of websites that you might find useful. The one is apopoulos.org. This is an online community of users, and we're uploading material on robotics and programming. And our emphasis here is on computer science. We also have the BotSTEM website for the European Erasmus project, where you can find a lot of resources on STEM subjects. Both sites are free and you can create your own accounts. But the main website is the eurobotics.net website, which hosts all the events for the European Robotics Week. European Robotics Week is preceded by the European Week of Code events, which as of 2 years ago, it has a duration of actually 2 weeks. So even though it's called European Week of Code and European Robotics Week, it actually has a duration of almost 2 weeks. Now, from this website, you can find more information about how it all started and how it started. One very interesting information is the national coordinators. Now, since most of you are coming from different countries, it should be quite useful to find your national coordinator, which can help you organize your events and also offer you support in the events. Now, each country has its own national coordinator. You can find your own from this page, and you can contact them since it has email and other contact information for you to find. In Cyprus, it's Yorgos Georgiou. I'm not quite familiar with the ambassadors from other weeks. These are volunteers, actually, and there are people who are willing to devote the free time to organize events. What characterizes these national coordinators is that they all have enthusiasm for what they're doing, and they are people who are quite knowledgeable on the subject. Now, in case you want to see what events are currently planned and also organize your own event, you can go to the events link. From here, you can also see past events, but let's see what's planned for 2019. We're going to see a map of Europe, which we can zoom on it, and every time we start a new event, a new pin, a new spot is highlighted on the map. It takes a few seconds, but it's going to come up. Here it is. Now, these are events planned in various cities. Even though it's called European Robotics Week, that doesn't mean that it has to be confined in European Union. There are people from all over the world planning events. Now, you can see here, if I click on one of the spots, it's going to appear on the map. I can find more information about the planned event. Maybe there's something near you you want to visit, or you want to learn more information, come in contact with the people who are organizing the event, and so forth. Now, if you want to create your own event, you can do that from the same menu, Events, How to Register an Event. Now, the first step, you have to create your own account in order to be able to register an event. Now, on this page, you can also see a short description of events already taking place. And of course, you can select a date, country, and event type to find information that are exactly suitable to your needs. Once you create an account, which is free and only takes a few minutes, by logging into your account, you can create your own event. Creating events is something completely free. It's also done almost automatically. Usually a national ambassador is going to approve your event. But apart from that, it's something that's done almost immediately. As of this year, there's a new procedure for creating the events. Once you log in, a link appears called Manage Events. Just wait for a few seconds for the screen to be updated. And you fill all the information required in the form. Here it is, Manage Events, giving all the information you require for your events. It is possible for a teacher to have planned more than one event. Maybe you will create an event for your school, maybe you work in another school at the same time, or you participate in a volunteer team, or you're also part of another group. So you can have various events here. Now, if we want to create a new event, the procedure is quite straightforward. This is the title. Let's say Robotics for Preschool. You can drag and drop your logo or an image you want to use to identify your event, and you can also select the date, whether it's a one day, all day, or it's a series of events that are going to take, let's say, one full school week. It's always a good idea to fill the location. Not only that it helps identify where you are, but also allows people and teachers that are near you to come visit, if that's possible, if it's an open event, and also come and see how things are going with you. We can also use Google Maps information to identify the location. A short description is always very helpful because it shows exactly what we're going to do there. And of course, the target audience. Participants expected is something that's giving more information on how many people we expect to have our event. Obviously, if we're doing something in our school, we know exactly the number of students that are going to participate. And we can also add some links here, let's say the website of our school or the website that we use for our activities, some useful links if we want to share, or any other files that we want to share with other people that might be interested in our events. Actually, this website, one of the main reasonings behind its development is for teachers to share their experience and their work. So it's a very good idea if you're planning an event to share with the other teachers what you're planning to do. This way, everybody benefits from the events. Now, this is the website. This is something that I'd like to see you creating your own content and uploading it and visiting your events. What we can do from that is organize the activities, what we're going to do. One of the main questions that I had in the previous days, and that's why I created a very small presentation here, is what kind of robots can we use in schools? Actually, this depends on what kind of school you are. If you're in preschool, like in kindergarten, one very good set that we found that works perfectly is the Bebot. The Bebot, it's a small robot on wheels resembling a small bee, and it can be programmed to move in squares. The Bebot is quite useful, and it's a robot that almost everybody who is in kindergarten knows and use. Another good robot to use is the robot mouse. Now, this is a robot mouse. They are quite inexpensive and they're quite straightforward. They use these tiles that we can create our own paths, and we can separate them using these purple walls. The mouse itself has direction buttons on the top where students can record the directions. Let's say I want my mouse to move 3 blocks forward, then take a right turn, and then move 2 blocks on the right. I will just press the recording button, click on the forward button 3 times, then I will click on the right turn button and then move again, press again the forward button twice. To help younger children, they can lay these cards on the green blocks so that they can visually design their program. And it's quite helpful because we can have scaffolds that enable students to start from a very early concept of programming and then move to much more complex, where they don't use the cards at all. They have to start from the beginning and they have to complete the entire labyrinth. Robot Mouse has its own cards where we can also follow the instructions to create our own playground or labyrinth, or we can create our own. Here it is. Now, another new addition for kindergarten is the Lego Coding Express. It's quite a new package and it's quite expensive actually, but this is an entry-level programming and robotics package for Lego. The train uses cars again to assemble the tracks, and also it uses colors to identify the codes. The robot can actually read the colors. This is an entry-level programming and robotics package. And if your school already has invested in Duplo blocks, because it's Duplo based, then you already have a lot of material to enrich your creation. Each pack is usually suitable for groups of up to 4 students. So this is a nice alternative if you want to have the construction element as well. And as I said, if your school has already invested in Duplo blocks. Now, for primary schools, there are also myriad of choices. If you visit online stores which sell toys or educational stuff, you see that they release new types of educational robots almost on a weekly basis. This is a local product called Engino. Engino, they are very flexible and very good quality plastic with motors and sensors, and the main CPU that we can program. They're quite inexpensive, and they can be also sold on the internet if anyone is interested in looking after this. In Geno, they are very capable, and they can be very easy to build your own robots or other constructions with them. This is a robotic spider. And they also have a very intuitive programming environment, which is compatible with most tablets and, of course, computers. It uses a drag and drop user interface, which is quite straightforward and very, very easy to use. It's also in English, and they are also translating other languages as well. Another very good option for robotics is the MBot from MakeBlock. These are very sturdy robotics, and these are Arduino based, but they use a proprietary Arduino board that makes it very easy to assemble your own robots. Quite remarkably, it's also kind of compatible with Lego if you see the parts on the top. But they also use their own added packages where you can assemble your new robots. Also very interesting is the fact that most of the components are common Arduino components. So if you want to replace, let's say, the motors, you can just order ordinary Arduino motors and install them, even though some modifications might be needed. This is an example of an add-on pack where we can give more capabilities to our robots. And it's programmed by a very versatile and free program called MBlock. We can download from the internet, but more on that later. Another new addition that's coming out in January for robotics is Lego Spike Prime. And this is an intermediary product between Lego WeDo Dio and Mindstorm EV3. It's coming out in January, and we just wait to see how this robot performs. But Lego is moving their programming environment from a proprietary to a more scratch-based environment. And this is one of the assembled robots we can create with Spike Prime. Now, for secondary schools and high schools, of course, one of the most used packages are the Lego Mindstorms, the EV3. There is rumors that going to replace them in the next couple of years, but this is one of the best packages that someone can use. This is the first robot we can create using the included instructions. It's a robot that can carry these colored cubes, and it's a very good introductory robot. A lot of the robotics contests that exist today are actually based on the Mindstorm CV3, like the first Lego League, the WRO, the Robotex, robotics competitions, and others. These are all competitions that have encompassed the Mindstorm CV3, so it's almost everywhere. Of course, a very, very advanced solution for programming, which is also extremely low cost, are the Arduino platforms. The Arduino is an open source platform, and quite remarkably, we can buy a fully programmable robot fully assembled for less than 15 euros on eBay or on other stores. They are not so easy to program compared to the previous robotics packages that we've seen, but they are quite versatile. and they are quite inexpensive. So if a school is on a very tight budget, it's very easy to create a robotics lab with Arduino for a very low cost. Now, there are various types of Arduino boards, but one of the most common one is the Arduino Uno board. As you can see on the image, this microcontroller has the pins on the left and on the right. The power supply input, we can have batteries, or we can provide power from using the USB port of our computer. And all the components from Arduino are extremely low cost, and we can use off-the-shelf components like LED lamps and wiring. Buying an Arduino on its own is not very useful though, so what you will require is also a breadboard. One of the main benefits apart from the cost is that to assemble an Arduino robot, you don't need to solder anything. We can just use the wires that are very easily to find, or usually we have in schools. We can just insert them into the breadboard, and we can create our own circuits. No soldering is required, which makes them suitable even for younger students who are not very keen on using soldering irons, even though showing students how to use a solder iron is a very, very good idea and very good skill. Again, with Arduino, buying bundles with sensors and other necessary equipment are very, very inexpensive. What you see here on the screen actually costs less than 15 euros. It contains a servo motor, it contains a power plug to connect a battery, breadboard, LEDs, necessary cables, even battery itself. So and a motor. Of course, one of the main difficulties with Arduino is that we have to program it using code, which is a very good starting point for high school students to learn to program using code. But for younger children, that's not so easy. However, we can download MBlock, which is a very, very easy to use, it's a very, very easy to use programming environment, and we can use MBlock to program the Arduino board. MBlock is an open source tool, and we even have an online version. You can download it from here. It allows us to select the type of robot we're going to use, and here we have Kodi, Mbot, various Arduino boards, microbit even, and by selecting our own robot, all the instructions related to our robot are shown on screen. So for programming our Arduino robot, it's no longer necessary to learn how to type code. We can just use drag and drop blocks to create our instructions. For example, here we tell our Arduino board to set the digital pin 2 output as high, so that we can manipulate all the motors or the servo motors or the LEDs or the sensors that we have connected to our robot. We are expecting to have and dedicated webinar, especially on Arduino programming using MBOT, probably early in the new year, either late January or mid-February. So we'll keep you posted about that. And we're going to play with Arduino. We're going to show you how to program it and maybe create your own inexpensive robot. Now, regarding programming, there are various tools that we can use to program a robot. Scratch version 3 is probably the best and most well-known programming environment for education in existence. And version 3 is way greater than anything previously used. Actually, a lot of companies creating robotics products for education, they are adapting Scratch-based solutions for programming. Now, in the Scratch environment, not only we can program, create games, but also we can use the extras supplied by Scratch to program a series of different devices and robots. These include the Makey Makey, which is not a robotics program, but it's very interesting. The Microbit, which is a very inexpensive microcontroller board. And we've also seen in the market robotic products based on Microbit. And of course, we can have the Lego Education Redo 2, Lego Boost, Lego Mindstorm CV3 supported here. And it's continuously been updated with more features. Let's say, for example, we have bought the Lego Boost, which is a package, robotics package, but for home use. The benefit of using Scratch is that we have a very friendly drag and drop environment that even extends the functionality of some of the already released robotics packages. For example, Lego Boost package is very, very limited in what it can do on the off-the-shelf program provided by Lego. However, once we start programming it in Scratch, then we have a very serious and a very easy to use robot that can do a lot of things that it wasn't meant to do. For example, we can program it to recognize color, and based on color recognition, it can function in a lot of different ways. Let's say, take all the red bricks from here and take them there. So Scratch is a very, very good environment for programming various types of robots. And of course, we can also program Arduino boards using Scratch, using the Arduino for Scratch plugin. Even though MBlock, you will find that it gives you similar functionality since it's Scratch-based as well. If you're looking for a lower cost robot that can suit various needs, we can also check out the Edison robots. The Edison robots are quite inexpensive. They are Lego compatible, even though they are third-party product, and through their online programming environments, it's very, very easy for them to be programmed to perform various tasks based on the different level of our students. For example, the EdBlocks app is one of the most intuitive and very friendly to use programming environments. It's quite straightforward actually, because from here we can program a robot to move forward for 1 second, then turn left for 1 second. Or we can enable it to play notes. We can create loops. And we can teach it when to start and when to stop events, including recognizing sounds. We can control it by clapping our fingers and even programming it to follow a line. Again, the same robot using the Head Scratch environment can be used in a much more complex way. Here we can control the robot. We can program it to follow a line, avoid obstacles, be controlled using the clap of our hands, or we can also program it to be controlled by our TV's remote. All these environments are quite similar, and this environment, Scratch.app, is actually based on Scratch. So everything goes back here. Now, this webinar was an introductory webinar to the Robotics Week of Code event, how to create your own event, and we also introduced you some of the main robots that are used in schools. As I previously mentioned, starting in late January or early February, we're going to start delivering more specific webinars, and we're going to cover the Arduino boards, which is a very inexpensive way of equipping your classroom with robots, but also the cost will allow your students to have their own robots, something which, quite sadly, students are not very easy to have their own Mindstorm CV3 or other robots. Now, there are many other robotics products in the market which are very good. Some of them might even be much better in some cases than the ones I mentioned. The list of robotic products is quite endless. So my suggestion, if you have the budget and you're going to buy robots, spend your time by examining various solutions available until you find something that it suits your specific needs. Now, this is all the information that I wanted to give you for today. I'm quite open to any suggestions or questions you may have. Is there anything? I see here a question. Yes, Steph Mats, Lego is for preschool, and it's actually designed for students 4 to 6 year old, and they use the Duplo. Yes. One of the robotics competitions, first Lego League Junior Discovery, makes use of Duplo, and it can also be used in conjunction with either the Coding Express or the STEM Park. Are there any other questions? Okay. I'd like once again to apologize for the technical issues we had at the start of this webinar. We make sure that we won't have the same issues with the following ones. We expect to have another 4 to 5 webinars until the end of the year, with more specific topics and going much deeper in showing more technical issues. But we're also quite open to your suggestions. If there is anything that you would like us to present, and of course, if it's something that we are capable of doing, we're very interested in hearing your opinions. My email is alexandros@mathesis.org. Once again, we have our Moodle website, botstem.org, that you can visit with a lot of information and material on STEM topics, and also our personal portal, apopoulos.org, which is bilingual Greek and English, and we're also translating in Turkish as well. So if there's nothing else, I'd like to thank you for being here with us tonight. Have a pleasant evening, and hopefully see you again late January or early February. Thank you and good night.